All right, welcome. Today, we are diving deep into the wonderfully weird and uncertain world of quantum physics. Now, this explainer is a little different. We're going to follow a trail of questions from someone who's just trying to get their head around the bizarre rules that run our reality. And it all begins with one heck of a question. And this is it. This is where it all kicks off. It takes something we all know, a very real, very volatile liquid, and just mashes it together with a concept that sounds like pure science fiction, superposition. So is a whole bottle of nitroglycerin literally existing in multiple states at the same time? Well, to figure that out, we've got to go back to the basics. So before we can even touch the nitroglycerin question, we need to understand the absolute foundation of all this quantum weirdness. And that is the principle of superposition. This is the exact point where the rules of our everyday world just fall apart. So what even is it? Well, to put it simply, superposition is a particle's crazy ability to be in 2, 3, maybe countless states all at once. It's not one thing or the other, it's all of them, all at the same time, just existing in this haze of pure possibility. That is, until we look. This slide really nails the difference. Think about flipping a coin, right? While it's in the air, you know it's going to land on heads or tails. It's one or the other. But a tiny quantum particle, like an electron, it can be both spin up and spin down at the exact same moment. That's the huge takeaway here. Our world, the classical world, plays by the rule of or. The quantum world plays by the rule of and. Okay, so this brings up a massive question, right? If the tiny little building blocks of our universe are this strange, why does the world we actually see seem so solid, so definite? What's the dividing line between that quantum and our classical or? And this insight from our source material just gets right to the heart of it. The key words there are observe and macrostate. And that line of thinking, well, it leads us straight to one of the most famous and, let's be honest, kind of morbid thought experiments in the history of science. Yep, we're talking about Schrödinger's cat. The whole idea is to link a cat's life to a random quantum event. That quantum trigger is in superposition. It's both happened and not happened. So, because the cat's fate is now tangled up with it, the cat inherits that quantum weirdness. Until you open that box to look, to observe it, the cat is, in a very real quantum sense, both alive and dead. It's a paradox, and it was designed to show how absurd it feels when you try to scale these quantum rules up to our big macro world. So, what saves the cat? What makes it definitively either alive or dead, not both? It's this, the observer effect. The simple act of measuring, of just looking, forces that quantum system to, well, pick a side. That whole cloud of possibilities collapses into one single concrete reality. The and becomes an or. And that brings us all the way back around to our nitroglycerin. The answer is a big, clear no. It is not in a state of superposition. See, it's a macro object. Every single particle inside it is constantly bumping into and interacting with or being observed by billions of other particles. The air, the bottle it's in, the light in the room. That constant, nonstop observation makes it impossible for it to ever hold on to a quantum state. But okay, hold on. This opens up an even deeper, even stranger question. When we observe something and its probability cloud collapses into the one reality we see, what happens to all those other possibilities? Do they just poof, disappear? Or does something even weirder happen? This little comment here points us toward a totally mind-bending alternative, the many worlds interpretation. It's a wild attempt to solve this whole measurement problem by saying that, actually, the other possibilities don't disappear at all. So you've basically got two main camps here. The standard theory, what's called the Copenhagen interpretation, says that when you look, all possibilities collapse into the one single reality we experience. The rest just vanish. But the many worlds idea, it says observation splits reality. In one universe, the one we're in, the cat is alive. But in another parallel universe that just branched off, the cat is dead. Every single possibility gets to play out, just in its own separate universe. Trying to grapple with ideas like parallel universes, that's not just a physics problem anymore. It's a deeply human one. It starts to challenge our basic perception of what's real, and that can feel, well, pretty overwhelming. And I think this comment right here is something we can all relate to. Quantum mechanics is famously, notoriously difficult. It's counterintuitive, it's meant to break our brains a little bit, and you know what? That's completely okay. Nobody has this stuff all figured out. But this is the most important piece of the whole puzzle. I'm getting there. The goal isn't to just snap your fingers and have this perfect, complete understanding. The real prize is the journey itself, that slow, satisfying process of piecing together the incredible mysteries of our universe. Because really, at the end of the day, that's what this is all about. It's about staring into this vast, deep unknown and not feeling scared, but feeling this incredible sense of wonder. The beauty of quantum physics isn't in knowing all the answers, but in realizing just how deep and mysterious the questions really are. So, I'll leave you with one final thought to chew on. If the act of observation is what turns all that quantum probability into a concrete reality, what did the universe look like before there was anything or anyone around to observe it? Was it all just an infinite ocean of shimmering, uncollapsed possibilities? The mystery, as always, continues.